Hi, in this video, we'll walk through the solution for Preppin Data 2022, week 27 in Alteryx and Python. We'll start out by looking at the requirements for this week, and then we'll look at the Alteryx solution, and then we'll look at the Python solution. So if you just want to skip to the Python part, you can use the chapters below. So this week is a fun challenge. It's the first in a series of 4 beginner level challenges for the month of July, where we're going to look at data prep fundamentals. So this week's challenge has a single input, and it's a CSV file. And it's just got product and order level details for the Chin and Beard Suds Company, which is a fictitious soap retailer in the UK. And they show up a lot in the Preppin Data challenges. So we've got data about when the sale occurred, how much it was, the product that was sold, the product in the scent, and then the store that sold it. And we're going to need to parse this product name apart. So the product name is the product type, which is either liquid soap or bar soap, and it's concatenated with the size. So in this case, 25 milliliters. So we'll need to parse that. So in addition to parsing, we'll need to do a quick unit conversion, and then we'll need to aggregate so that our output looks like this, where we've got the quantity, the store name, the region, the total, the sum of sales, and the count of orders. And we also need to split this so that we're outputting a separate file for bar soaps and a separate file for liquid soaps. So let's head over to the Alteryx solution. All right, so we'll start out by inputting our data with an input data tool, and then we'll navigate to that input file. All right, so the first order of business is to parse out that product name. So I'm going to go ahead and run the workflow. I'm going to use a regex parse tool for this, and we're going to parse the product name field, and the output method is going to be parse. And when I'm doing these kind of parsing regular expressions, I like to just take an example from my actual data. So I'm just going to take one of these examples here and copy that so that I can use that kind of as a template that I can write over in my regex parse tool. All right, so I'm going to paste that in there. So in regular expressions, parentheses indicate capturing groups. So I'm just going to put parentheses around the things that I want to keep. So we're going to use regular expressions to match different parts in this string and then output them. So you can see I have 3 capturing groups up here, and now it's created 3 new columns down here. So this first capturing group is going to be the product type, and it's going to be either liquid or bar, which is going to be capital and lowercase letters. And so I'm just going to be a little bit lazy, and I'm going to use the period. I could force it to only match letters, but I know that's all I'm going to get here. So a period in regex is any character. And then I'm going to do a period asterisk, which means any character, and then the asterisk means any number of times, so 0 or more. So what this is essentially going to do is it's going to match all characters that exist before the space dash space. All right, so we're going to skip over the spaces and dash because we don't want to actually return those. We want to match them because we expect them to be there, but we're going to skip over them. All right, and then the second thing we want to capture is this number, the quantity. And so that's always going to be digits. So we'll use the regex shorthand for digit, which is /d. So that represents any digit 0 through 9, and then a plus sign, which means 1 or more. So this is essentially going to, after the space dash space, it's going to match digits until it runs out. And then so finally, whatever comes after the digits, that's going to be our unit. And in this case, it's ml for milliliters, but it's going to be some combination of uppercase and lowercase letters. So I'm going to go ahead and again and use period asterisk for any character, any number of times. And so essentially what that's going to do is after we capture all the numbers, whatever comes after the last number to the end of the string, that's what is going to go into that third capturing group. So let's rename our columns down here. So our new columns are going to be product name or product type. And that's a string, we can leave that. Quantity. So this is going to be a number. We need this to be a number because we're going to perform some calculations on it later. So all of these are integers. So I'll just go ahead and make this an integer now. We may want to make that a double or fixed decimal in case there might be decimals in the size later on. And then the last capturing group is the unit, and that is also a string. All right, so we'll annotate that. All right, so the instructions say next we need to split our workflow into two paths. But before I do that, before I split it up, I notice if I click on the connector here between the two tools, I can see the metadata that's kind of flowing between those two tools. And I can see my sale value is being read in as a string. And we need that to be a number because we're going to have to sum it later on. So I'm going to use a select tool over on the preparation menu. And I'm just going to go over here and change the type in sales value to fixed decimal. And I'm not sure what kind of sales volumes we're dealing with here at the Chin and Beard Suds company, but we'll go ahead and do 12 digits with 2 of decimal precision. So I just entered 12.2. All right, so now we're ready to split the workflow into two paths, one for liquid and one for bar soap. So we'll use filter tool using our new product type column where that equals liquid. And so then it says for each path in the flow, we need to clean up the quantity field to just leave the values, which we've already done in our regular expression. And then for liquid, we need to ensure every value is milliliters. So I'm just going to throw on a temporary summarize tool. So out of my filter tool, we said where product type is liquid. So if that's true, that's going to come out the true. And if it's not liquid, which in our case would be bar soaps, that would come out the false. So I'm just going to hook up a summarize tool temporarily so that I can see what kind of units I'm working with. So I'm just going to group by unit and I'll run the workflow. All right, so it looks like we just have liters and milliliters. So those are the only two units we have to deal with. We'll get rid of that summarize tool and then use a formula tool. And so we'll just use a conversion factor to get all of our values into milliliters. So I'm going to just overwrite the existing quantity column. And I'm going to take the original quantity times a conversion factor. So if the unit is liters, then we're going to multiply by 1,000. Otherwise, we'll multiply by 1 to keep the original value. And we'll annotate that. Okay, so next we need to sum up the sales for each combination of store, region, and quantity. So we'll use the summarize tool for that. So store, region, quantity, we'll group by. And to select multi-select, I just clicked one and then held down the control key and then clicked the other two to select multiple. And then sale value, we need to sum that. And then we need to get the distinct count of orders. And so in the output file, we're trying to match this sum of sale value is just called sale value. So I'm just going to delete the prefix. And then this order count of the distinct count of orders needs to be called present in N orders. So we'll rename that as well and we'll annotate. All right, and finally, we need to output that to a liquid file. So we'll just call that file 2022 27 liquid. And just for consistency, I output all of my Preppin Data files with UTF-8 encoding. It doesn't really matter for this challenge, but we'll do it to be consistent. All right, so that's our liquids taken care of, but we need to also take care of our bar soaps. So the only thing we have to do differently for liquids was do that conversion, but we don't have to do that for bars. So I'm just going to copy these two tools and paste, and then connect them up to the false output. So remember, the false output of this filter tool is bar soaps or not liquid soaps. And then we'll just change the file name to bar instead of liquid. And so that is our workflow for week 27. Before we head on to the Python solution, I did want to mention anytime you're copying and pasting groups of tools multiple places in your workflow, that is a good indication that you have a dry error. Dry is DRY, don't repeat yourself. So anytime in Alteryx that you're copying a chain of tools and then pasting that multiple places, that's usually a good indication that you should probably have a macro so that you can kind of reuse those sets of tools over and over. Or in this case, it might be an indication that you could simplify the workflow rather than having two branches that do mostly the same thing. So I think, this challenge is really just designed to show you how you could do that if you needed to have two different processes for these two types of soap. But if I were to do this particular exercise, for a real work application, I probably would not split the workflow. I would probably do it something like this. So you can see the first three tools are exactly the same. It's just when we get to the point where we're going to split the workflow into two paths, I just didn't split it. And so I just sent all the records into the conversion calculation. So again, this is the exact same conversion that we did before where we're converting liters into milliliters. So the bar soaps don't have any units. They're just the count of bars. So they're just going to be multiplied by 1. And then I added a second function here that I'm just concatenating I'm creating the file path. So I'm taking the file name and then I'm just inserting the product type, bar or liquid, into the file name. And so that's going to allow me to output two separate files, even though I don't have two branches in my workflow. So then the only thing that I changed in the summarize tool was I just added that file name or file path field as a group by, because I need that in my data for the output. And let's just run that so we can see what it looks like. All right, so we can see that we have the store region and quantity rollup that we wanted. We've got all of our bar soaps have bar in the file path, and then all of our liquid soaps have liquid in the file path. So when we get to the output, it's just going to group everything with this file path and send that to the bar file, and then it's going to group all these rows that have liquid and send those to the liquid file. So over my output tool, the change that I made was I came down here and I checked this option to take the file or table name from the field. And then I chose change entire path, and I said use the file name field to get the path. And then I unchecked keep field in output because I don't want that file path in my actual output file. And so what that's going to do is it's going to output two individual files, one for bar and one for liquid. So you do pay a tiny penalty in Alteryx for, you're performing this filter, this formula on a fraction of the rows, in the branched workflow, whereas you're performing that, all of your rows have to kind of go through that conversion factor in the single path workflow. So you do pay a little bit of a performance hit down here for that, but it's minimal. So I tried just the original data set's, I think, 4,000 records. So I tried blowing it up to about 1.1 million records just to see if there is, a material difference in the time. And it was very small. So I ran this version of the workflow a bunch of times, and it averaged about 4 seconds per run, so 4.0 seconds per run. And this unsplit version, I ran that one a bunch of times, and it averaged 4.4 seconds per run. So really tiny amount of difference for what to me would be a little bit easier to follow and a little bit easier to maintain, as long as you don't have to do anything materially different to the liquid versus the bar side. So that's it for the Alteryx solution. Let's move on to Python. All right, so for the Python solution for week 27, I'm going to start by doing my imports. I'm going to use NumPy where in this solution, so we'll import that, and then we'll also import pandas. So we need to input our data. So we'll just use that. We'll use pandas read CSV for that. I'm going to create a new data frame called df, and I'm going to use pandas read CSV to read in the file path that we have for week 27. I could use some additional parameters here to parse the date, but we don't really need that for this solution. So I'm going to run that, and let's just use df.info to look at our data frame. All right, so info gives us kind of the metadata about our data frame. We have 4,063 entries in our index. We have 7 columns here, and all of them have 4,063 non-null values, so that's good. Our sale value, which we're going to need to sum up later, so we need that to be a number, that is being read in as a float, so that's good. Like I mentioned, the sale date is being read in as a string, an object or a string, and we could certainly parse that if we wanted to, but in this case, I'm not going to because we're not actually going to use that field anywhere. So it looks like we're ready to go. We've got our data imported. and let's start processing our data. All right, so the first thing we need to do is we need to break out that product name field into product type and quantity. So just as a refresher, what's in there, let's take a look at our product name category or product name column. So remember, it's the product type, so liquid or bar soap, and then a space, a dash, a space, and then the quantity or the size, I guess, of the carton or bottle that the soap is in. So I am going to use extract for that. So I'm going to add 3 new columns to my data frame: product type, original quantity, and unit. And to get the data for those 3 new columns, I'm going to take the product name column and the string accessor, and then I'm going to use the extract method to split that into 3 parts. So extract just takes a regular expression, and in regular expressions, the parentheses indicate capturing groups. So those tell us we want to match this part of the string and then return it. And you can see I have 3 sets of capturing groups here, 1 for each column that I want to output. So it's just going to assign those to the new columns in order. So the first one will be product type, the second one will be the original quantity, and the third one will be unit. So what my regular expression is doing here, so all of these are in the format product type, space, dash, space, the size, the numeric size, and then the unit for the size. So in this case, the size is 25 and the unit is milliliters. So what my regular expression is doing is the first capturing group is getting anything that is to the left of the space dash space. So I'm just saying period, which is any character, and asterisk, which is any number of times, so 0 or more. So this is basically just matching anything from the beginning of the string until we get to the space dash space. And so we don't have the spaces and dash inside parentheses because we don't actually want to match those. We just want to skip over them, match them and skip over them. So then the next thing I come across is the number. So this is always going to be numeric. And I'm going to use my regular expression is going to be /d, which is shorthand for a digit 0 through 9, and then the plus sign, which is 1 or more times. So I'm basically going to match at least 1 digit, and I'm going to keep on matching digits until I run out. So in the case of this example, 25 milliliters, it's going to match the 2 and then match the 5, and then it's going to stop. So then finally, my last capturing group is going to be the unit. And I've again just used, this unit is always going to be either an uppercase or a lowercase letter. And so I could certainly limit my regular expression to only matching letters, but I'm going to be lazy and use the period, which is any character. And then the asterisk again is any number of times. So this is essentially, once we run out of digits, it's going to match anything after that till the end of the string. So in this example, after it matches 25, then it's going to match ML, and then that's it. All right, so let's run that. And let's look at our new columns. So you can see now we have the product type, the quantity, and the unit appropriately parsed. So here's where I'm going to deviate from the instructions. So the instruction specifically said to branch the workflow into 2 paths, 1 for liquid soaps and 1 for bar soaps. I'm not going to do that. I don't think it makes sense to do that in the Python solution. We certainly could just slice the data frame into 2 parts and assign it to 2 new data frames, 1 for liquid and 1 for bar, but I just don't think that makes sense to do here. And when we do the unit conversion, which is the only thing that's different for liquid soaps versus bar soaps, NumPy is really efficient, so we're not going to pay that much of a penalty for not splitting. So we'll just continue on with a single workflow for both product types. All right, so my unit conversion, I'm going to create a new column called quantity, and that quantity is going to be equal to the original quantity that I parsed out of the product name, converted to an integer. So when I extracted that number, say 25 or 4, that's going to be typed as a string initially. So I need to convert that to a numeric type so that I can multiply. So I'm taking the original quantity column and I'm just converting that to an integer. And then I'm multiplying that by a conversion factor. So I'm using NumPy where here, which is basically like an if statement. So it's kind of like the if function in Excel. So we're basically saying where the unit column is L for liters, then I'm going to return 1,000. Otherwise, I'm going to return 1. And so any records where the unit is liters, it's going to multiply by 1,000. Any other row that's not liters, it's just going to keep the unit as is. And how I decided to do that that particular conversion is, first of all, I looked at my df unit column, and then I just took .unique, and that will tell me all the unique values that are in that unit column. So I can see I have milliliters, liters, and X. And the only thing, so the instructions tell us we need to convert all of our liquids to milliliters. So X is just the count for bar soap, so I don't need to convert that. Milliliters are already milliliters, so I don't need to convert that. So the only thing that I need to convert is things that are in liters. So that's why I built my where statement like this. All right, so now that I've got my my product name split out, I've got my quantity reassigned, now I need to do the aggregation. So we need to sum up the sales for store, region, and quantity. And then we need to count the orders for each combination. So we'll first need to create a grouper. So I'm going to call the result, my aggregated result. I'm going to assign that to a new data frame, and I'm going to call that df out. And we'll set that equal to, so I'm going to have to chain a couple of operations. So I'm going to go ahead and wrap this in parentheses so that I can wrap it on multiple lines. All right, so I'm going to take my original data frame df, and I'm going to create a grouper with group by. And the fields that I want to group by are store, region, store name actually, so store name, region, and quantity. And so I do need to add in the product type. So I know we're only supposed to group by store, region, and quantity, but remember, since I didn't branch my workflow, I need that product type in here so that I can tell which file to output it to, because we have to output a separate file for bars and liquids. So we'll put product type in here too. All right, so I'm going to group my data by product type, store, region, and quantity. And then I'm also going to use as index equals false, because I want to return those as columns of data and not as a multi-column index. All right, so now I've created my grouper. Now I need to add my aggregations. So I did this, there are a variety of ways you could do this, but I use named aggregation using ag. So I'll just paste that in here. Oops. I'll just paste that in here. So I'm using named aggregation here using the ag method in pandas. And so the first value is the name of the column that I want. So this new column that I'm created, the new column that I'm creating, the aggregated column, I want that to be called sale value. And that is going to be equal to the sale value column summed. And then I also need a second aggregation, which is the present and in orders. And that is going to be equal to the order ID column and the number unique, which is like count distinct. All right, so we can run this just to see what it looks like. So we need to run this unit conversion too. All right, so let's look at our df out and see what that looks like. So we can see now we have our data summarized by product type, store, and region. We've got the sum of sales in present and in orders. So we're almost there, but the problem now is that in the file we're trying to match, the column headers do not have underscores in them, they have spaces. And so with named aggregation, you can't have spaces in the column name. So that's why I put underscores. So we do need to rename those columns so that they have the names that we're expecting. So I'm just going to use rename for that. And I'm going to rename columns. And then I'm just going to use a dictionary rename, or I'm sorry, I'm going to use a lambda to rename. So a lambda in Python is just an inline, a little small inline function. And so this is, in this case, X represents the columns. So this is going to act on all of the columns of my data frame. And so it's going to cycle through all the columns. And for each column, it's going to use just the standard string function replace. And it's going to replace underscores with spaces. So now if we run that and take a look at our df out, we can see that our column names now have spaces instead of underscores. So it just applied this function x.replace to all of the columns. All right, so that is our data set pretty much done. But the last thing we need to do is output it to a CSV file. But we actually need to create two separate CSV files. So we need one file. So we need these records to go to the bar file, and then we need all of the other records to go to the liquid file. So one way, I mean, we could certainly do that in two steps, right? So we could just use string slicing, or I'm sorry, data frame slicing to get out the just the fields that we want. So we could say something like, let's take our df out data frame and let's return all the records where product type equals liquid. And so we can just run that to see what it does, and we can see we're just getting records that are liquid. And then we could chain on to that. So let's wrap that in parentheses. So then we could chain on to that. Let's see, we'll need to first drop that extra column, right? So we don't want this product type to go out into our file. We just need it to tell us where to split. So we'll drop that column. So we'll say drop columns equals product type. We don't need that column anymore. We've already done the splitting. All right, so so now we've dropped that column. What else do we need to do? Oh, we just need to do the to CSV. So we'll use .toCSV, and we'll give it the path we want to output to. So this is liquid, so we'll call that liquid CSV. And let's do index equals false. And so by default to CSV, when it outputs to a CSV file, it outputs this numeric index as well. And so we're just telling it, don't do that. All right, so if I run this, this will just create my liquid file. So it's going to take the rows out of the data frame where product type is liquid. It's going to get rid of the product type column, and then it's going to output that result to CSV, to the liquid file. But I have to do that twice because I also have to do this for my bar file. So I actually just created a loop and just let my loop run 2 times, once for each file. So I said for t in So I'm just going to take all the unique values in my product type column. So this is just going to return a list of my unique product types. So let's just run that. So we can see that's going to return a list with 2 values, or an array with 2 values, bar and liquid. And so when I say for t in, it's going to run 2 times, one for each value in this list. And each time that value is going to take on that variable t is going to take on that value. So the first time my loop runs, t is going to be equal to bar. And then the second time the loop runs, t is going to be equal to liquid. So now I just need to replace liquid here with t. So now this will slice my data frame based on whatever product type we're working on at the time. This doesn't need to be changed, but I do need to change my path here. So I need to replace this liquid with t. And so I'm using an f string here. So I've just prefaced it or prefixed the string with f to indicate that it's an f string. And so f strings are great because you can just put these placeholders in curly brackets. So in my case, it's T. So an f string, it's just going to evaluate whatever's inside the curly brackets and then just replace that with the value. So you can put functions in here. You can put all sorts of things in here. In our case, it's just a single value, but it will just, when it runs, it will evaluate what's inside the curly brackets and then replace all of that with the value. So in our case, each time this runs, T is going to take on the value of either bar or liquid. And so this is just going to replace the curly brackets in T with the word bar or liquid. And so there we have it. That is the Python solution for week 27. So once you finish your solution, please do share it with the rest of the Preppin Data community. If you participate in Tableau Prep, there's a forum on the Tableau community that you can participate in. And if you, like me, participate in some of the alternative tools, you can share on Twitter and on GitHub. So please do share a solution and use the Preppin Data hashtag. It's Preppin Data with no G. And if you go to the Preppin Data blog post down there at the bottom, it will give you the particulars of the hashtag and the people you should tag in your post. And then there's also a participation tracker where you can record which weeks you finished and give some feedback to the creators on how hard you thought the challenge was. So all that's totally optional, but it's really fun to participate in the community and see who else is participating in which tools, and also to see the other solutions. So anybody out there who is using Alteryx and or Python, it's super fun to see all the different ways that people solve it. So I definitely learn a lot from looking at the other solutions. So I will see you out there and hopefully see you next week for week 28.